If you had your own AI assistant, what's the first thing you'd make it do for you? If you had your own AI assistant, what's the first thing you'd make it do for you? You can raise your hand and answer, or you can type your message. If you had your own AI assistant. Hello? Will you make it do your assignments, write code, cook? If you had your own AI assistant.
Yes, actually. So I think we have Samantha weekly.
Okay, thank you so much again. Okay, thank you so much. As I said earlier, AI is something that most of us now, as it is today, you are supposed to have. For personally, I can say when it comes to my daily work routine, especially when it comes to scheduling projects, maybe there is a way that scheduling projects, that's number one. You can use it in online lighting, and then I also use it when it comes to, especially nowadays, when it comes to interviews, most especially those interviews that are virtual or in any online platform. I think that's a big thing for me. Okay.
Yeah, that's great. Do you have another trial? Anyone wants to share with us what they'd like to have their own AI assistant do for them? Okay, we can continue. Now, this event is all about unpacking artificial intelligence, what it really is, how you can start using it, beginner-friendly AI tools. I'm sure some of you have used AI tools before, maybe knowingly or unknowingly, but I'm sure you've interacted with the AI tools. And most importantly, how you can turn this knowledge into a real career opportunity in 2025 and beyond. So we are living in one of the most exciting times in tech. AI is reshaping industries, creating new jobs, and transforming how we think, learn, and work. Most people, even now, they're wondering whether AI will take their jobs and all that. So in this event, you learn more about how to, whatever your line of job is, how you can use AI also to make your life better or make your work easier. So, and tonight you'll get to understand how to be a part of the AI revolution. Okay, now to guide us through this journey, we have a very special guest with us. Please join me in welcoming Mr. Ezekiel Maina, an experienced AI engineer and one of the leading voices of in helping people understand and build careers around artificial intelligence. So without further ado, let's give a warm virtual welcome to Mr. Ezekiel Maina as he takes us through AI demystified from beginner tools to career opportunities. Over to you, Mr. Ezekiel. Mr. Ezekiel?
Present. Thank you very much.
Yeah, you're welcome.
Hope I'm edible enough.
Yes, you are.
All right. Thank you very much. I'm Ezekiel Maina. I'm an AI engineer. I work at the Maseno Center for Applied Artificial Intelligence here at Maseno University. And I'm also an incoming PhD student. I deal with AI ranging from computer vision side of it, NLP side of it. And I'm very glad to have Leon Maina from Simba AI here. I'm sure Leon can agree with me that the talk about AI, the goings about AI, is something that we can't cover AI in just in just an hour session, right? But I will try as much as possible to have us guided in terms of if you want to start on AI, what will be the best way to go about it, and what will be the best areas of interest to go about it in the matters concerning AI. So with that, I'm not sure if my screen is very visible. All right, thank you, Leon. artificial intelligence is something that we have been seeing and has been booming currently. Now, it is all about machines having to behave like a human being in different dimensions. So we have dimensions in which a machine will see, a human being sees, a human being hears, a human being talks, a human being moves, and everything like that. So when we look at artificial intelligence, we are just trying to mimic human beings. And the biggest problem we have in the area of artificial intelligence is that we have a lot of machine learning enthusiasts who just know about machine learning. And the biggest question they ask themselves is, will AI take over? You know, those are the enthusiasts. Ask them, what do we mean by forward propagation when we mention neural networks? They have no idea. Ask them, what is the impact of having a sigmoid function instead of a ReLU function for a neural network? They have no idea. So when I look at this session today, I will first want us to understand what is the mathematical side behind AI and how can we be able to balance between all the things and all the feeds available in AI. The coding and everything about it, that is just the tip of the iceberg. The other side of it is understanding what these algorithms are all about. We know about linear regressions, but how does it do that? We know about GPT, but how? What is the mechanism behind ChatGPT's operation? So, as I said, human beings can see. That is the perceiving, the seeing part of AI. So we have a section on AI that deals totally with computer vision. All right. These are just subfields that I'm mentioning. We have the ability to talk in our natural language. And a natural language is a language communication system that has a grammar on itself. And human languages, spoken languages, sign languages are all part of natural languages. So human can talk. What about machines? There we have a section on AI that is all about natural language processing. All right. So we now have another task. When you look at the chatbots that we have in our systems, that when you enter to Facebook, you are able to talk to Facebook in a given language. Before you even reach to that, you hear that, oh, as when we had the launch of Simba, that is trying to have local languages involved in that platform. So all that lies under a technique called natural language processing. Human beings move. How does AI ensure that it can be able to bring things that move or locomote? That's another subfield called robotics. All right. So whatever human being can do is what AI has been having different subfields to help it achieve in moving. So if you are thinking that AI started just during ChatGPT's maybe launch in Corona period or 2022 or like that, because I'm sure Billy and I are alumni of the same university. When he was finishing, I'm not sure if really ChatGPT was there. So whatever Billy got, it was really his brain. But right now we have students who are applying a lot of AI tools and everything in whatever they do. AI started a long time ago. It can be dated to years of what we call the Turing experiment. So Alan Turing had an experiment whereby machine and a human being are set in two different sides. And when the human being is interacting with this machine, he should be able to judge that, hey, I think this is a human being that I'm talking to. So the level of success between the engagement between him on the other side, and they are not able to see each other, by the way, they're in two different sessions, but they interact. And the other side, the machine itself was to make itself very, very human. And here it is dealing with a human. So after that, the experiment deducted 4 things that when we're looking in the perception of AI, we have 4 different areas that are very core to us. Thinking rationally, acting rationally, thinking humanly, and acting humanly. When you see like this and you hear earthquakes, you move fast before even thinking, should I move? You know, because we have the reptilian side of our brain. Then we have the new brain or the neocortex that now talks about the knowledge and everything. But when you hear a tire blast, like, the reaction there is a rational reaction, which comes all the way from what we call the neuro side of it. So even in the advancement of AI, we also have another section that is called neural networks. I'm not sure how we shall take about this, but I'm sure you are going to be bombarded with a lot of things. But one of the key things that you are going to have with this session, Edwin on Koba is on board, and he is having one of the presentations of how you can apply NLP tasks. So we'll be having a demo on NLP. I will also be taking you through a demo on combined NLP and computer vision on what we have been doing about sign language and how we have been able to achieve that. So let's dive on to it. We have a lot of all these AI stuffs and everything. Two major categories is one on how these things learn. So yes, we have AI trying to mimic human being. We now have machine learning, where we want these machines to learn. We're exposing them to learning environments, okay? Then we have deep learning. So deep learning is a subfield of machine learning, where now we are exposing them to deeper, sophisticated data, all right? So we look into neural networks, which is one of the commonly techniques around deep learning and all that. Then we'll be able to see some of the examples and some of the models that you can be able to use even at your own pace and everything. So the major two teaching or learning ways in machine learning are the supervised and the unsupervised learning manner. We have another one called reinforcement learning. That is one is more of robotics, the field of robotics, which includes navigation. So in reinforcement learning, it is not a major one, depending on where we are currently in Kenya, but with the startups that we have, like the engagements with the Simba AI and AI for KSL, Codevertex and everything, we are trying at least to have navigation or robotics part of what we do. Actually, there's a lab in the Kut called DSA, and they do a lot of robotics, as well as a lab in JQuat. They interact a lot with JHub, and they have a whole robotics section. In Makerere University, we have a movement of Mark AI, and they do a lot concerning that. We have the Christian University of Uganda. Those ones now are dangerous when it comes to robotics in Uganda. So reinforcement learning is all about, yes, we are teaching this machine here, and when it does the right thing, we have a reward punishment mechanism. So yes, you have done well. So when the machine engages in later engagement, it will be like, oh, okay, I did well, this is what I do. So when you punish it, it is in terms of reward. It could be in terms of points. It could be in terms of setups of 5 scales, 3 scales, 8 scales, or whatever scale that you are having. But the major methods of learning up to where we are in the state that you can comfortably say are supervised and unsupervised. So when you deal with supervised learning, machine learning and AI is all about data. The essence of AI is all about data. And AI, by the way, employs one very simple principle: garbage in, garbage out. Now that one is in respect to data quality. So when you are training your AI model with low quality data or poor data, then you are expecting a model which is a replica of your data. So it will be a very, very poor model, right? But when you do that with a good model, good data, then you're very, very open to the kind of beautiful model that you're going to have in terms of performance. So in supervised learning, we ask ourselves, what do you want to teach here? We have the data, which has the training set, and the training set has the labels as well as the features. So you are giving guidance on whether these labels are true and everything. Maybe they could be labels of 3, average, best, poor. Labels are now the classes that you want to predict. All right. So in the prediction of supervised learning, you either predict a classification, that is a category, or you predict a quantity. For example, linear regression. So I shall take us through logistic regression and linear regression on the mathematical side of it, so that when you see ChatGPT operating or any other AI model operating, back of your mind, understand there's a lot of mathematical concept behind it. All right. So KNN, Logistic, SVM, those are some of the algorithms that we have under the classification. On regression, which is, for example, when we are dealing with weather forecasting, we deal now with the linear regression, the ridge regression, lasso, all those are algorithms under regression. On the other side of unsupervised learning, we don't expose the model to whatever class we have that we have already sorted in terms of the labels. So what we want to do we want to do a technique called dimensionality reduction? Good. We now employ a technique called PCA, principal component analysis. If you just want to cluster things together, you don't want to have the labels of them already. For example, you have data that contains apples, you have another data that contains fruit that is maybe lemon. But when you are training in your data, you don't label this as an apple and you don't label this as a melon. You want the machine itself first to learn the pattern of the data first before anything else. All right. So after all those surfaces and everything, let me now take you to a simple mathematical concept behind one of the best AI areas in regression. A regression is all about predictive mechanism. And whatever we want to predict here is data that is continuous in motion, that is weather forecast and everything. It's very simple concept. But I bet you the mathematical angle is very different. Leave alone the coding. Coding, you can tell ChatGPT, write me a code of linear regression. But do you understand what it does? So that is the biggest motivation behind me viewing AI in the mathematical perspective. It's all about fitting data into a straight line. But hey, when you are having this motion that is moving, we have different parameters involved. One, how many variables do you have in this regression? Are you just predicting rain, or are you also predicting rain together with sunshine? That is what we mean. In this line, from your mathematical background, you understand that we have the gradient and we have the C, which represents the y-intercept. So the C is where now the value of that axis when it is in the lowest or the zero mark of it. So as we are shifting towards this point, you understand that we are trying to find a line where we will best fit this kind of data. So is this good for textual data? No, it is a problem because we will have to plot in terms of numerics and everything. So when you are dealing with the textual data, you will have to do either transfer, that is dealing with encoding. We have a technique called one hotkey encoding. You transfer all whatever you have to numerics before doing what? Dealing with a linear regression algorithm. Or best yet, you can deal now with classification, where we can look at NLP technique that will deal with the textual classification. So we want to have a linear relationship between an input variable and a real valued output variable. The output, of course, will depend on what we are having as the input. So what we are trying to have here is that the input that we are putting in this model or in our data, actually this we are now describing the data, is just the features. Then the output variable is the target. So if we want to predict rain, we have measurements of previous trends. So what we want to predict now is a single content, will it rain? Okay, or if it rain, what level or what degree of humidity are we expecting and everything like that. So in supervised learning, the data set that we shall be using in the training of the model is a training set. The data set that we shall be using in the evaluation of the model could be either a validation set or a test set. All right, I will take you through bias and variance and errors of what will happen if you expose this to there. Remember, the fuel behind artificial intelligence is all about data. All right, so we'll have to denote the number of training examples with M. Don't worry about the mathematics. I got you sorted in the slides. So this means when we are having xi, yi pair, in this equation where we're having the ith examples, we're saying for the features of row I, all of them, so remember you are representing them in any format that you are using. So the ith example has the Y label. So you have this feature, and of that example or that row of data, you still have an accompanying label. So the first training set will include a set from whatever range you shall be having. Of course, 1 all the way to M-1, if that is the ratio. Some of the ratios of dividing the split, which I wanted to tackle later, depend on the kind of literature that you have done. If 60-20-20 works, where 60% is a training, 20 is a validation, 20 is a test set, no problem. If 80-20 works, where 80 is a training and 20 is the testing, no problem. You can expose them to everything. So now, when we want to classify something in a linear regression manner, we have the hypothesis function. It is not something big. It's just a mapping function that we want to predict for an output. What is the formula of a line? Y is equals to mx plus c. That equation itself gives a relationship between y, which is the output, and the variable inside, which is x. So for different values of x, we are expecting a different value of y. All right. So this is just what we have. So we have the x, the hypothesis function, and the output variable y. So in 1D linear regression, that means we have one feature. The hypothesis function is just theta naught, theta 1, x. This is just the same as y is equals to mx plus c. No big deal, but I will tell you where we are now coming from. So if you are training a model, a linear regression model, and you are having just one feature, the parameters will be 2. Why? Because what will happen if, by the way, in a gradient, when we're calculating the formula for a line, we have y is equals to mx plus c. Do you understand the importance of the c of it? It's because if we are having x is equals to 0, and we don't have the c, then it will be as equal, y is equals to mx, which will also be equal to 0. So we are not going to have a plot in any manner. That is why we always add the c there for us to have a movement or a plot. Okay, so whether it is 0, we shall always get an output y. Is that a problem? No, it is not. Reason being, the plus c applies to all other features. So there is standardization of that. So when we are having the linear regression, we have to calculate what is the error that we're having. And linear regression adopts what we call the chi-square statistics. Sorry, a little bit mathematical, but at least you'll have a reason to say this linear regression works like this and like that. So in chi-square, you have, of course, the plane, the xy plane, and you have already the dots that you're already having. Now, when you have already predicted, or you already trained the model, you want now to predict. So for each and every point, the model has done a prediction. So in chi-square, you get the difference between the actual and the predicted. So this actually is what we are calling the observed. So what we mean is that we'll have a formula which is written there, and this formula will be giving us the summation of the errors that we are having. So when it comes to linear regression, each and every model in AI, the one that you choose, each and every algorithm, it has an evaluation matrix that goes with it. All right. In NLP, when we're training a text model, a classification model, the metrics that you have there are based on the confusion matrix. I will tell you what that is later. But when you are training a linear regression model, you will have a different metrics. So there's a problem. If you don't choose the right metrics of the model, then you might be evaluating your model wrongly. Okay, so we have the data that we're giving inside there, and we have the actual and the predicted values by the model that we have created. Then we have, which is the one that we're calling the expected. Then we are going to have what is called the cost function. So the cost function is what we're calling this global error between the predicted values, and we're getting them from the mapping function. So now, in linear regression, what we are trying to have is the mean squared error as evaluation metrics. So we say that this model has an error, this. But you can say this error model has a precision of this. In textual classification, or when we're dealing with classification, the evaluation metric is about accuracy, precision, and one score, along many other things. But in linear regression, we have mean squared error, the root mean squared error, and all other evaluation metrics. So find the evaluation metrics that suits your model. So instead of now fitting the data with a straight line, in linear regression, as from the mathematical background, we want to deal with find parameters, theta naught and theta 1, that will minimize the cost. The cost, remember, is a global error. The global error means that we have added the difference between the predicted and the actual of each and every instance, and we have gotten value x. Okay, so what we want to do, let's observe this data set. For example, we have the x and the y here. So we have theta naught and theta 1. So for the values of theta naught and theta 1, we will have, you can set theta naught to be a constant, like for example, 0, right? Why 0? Because most of these models take 0 to be the constant side of the plus c. So the c there will be where the y-axis meets the line, that is a straight line in that plane when the value is 0. Okay, so what we want to do, we want to compute the cost when theta1 has been set to 0.511 and everything like that. We have the function. So first of all, we'll have to calculate the value of the predicted. Okay, so what you do, you have the formula. Okay, let me just take you back to the formula, which was theta1, theta naught plus theta1 plus x. That is the formula that we're dealing with here. So you have the x there. This one will give you the predicted. Are we together? So theta naught plus theta1 plus x will give you the predicted. So you come here, you have already set 0 to 0, theta naught to 0, theta1 to all these other values. The idea is get the parameters where theta1 and theta naught will give you optimal value. The optimal value means the global error, or the error in the predicted and the actual values are equals or close to 0, so that you can say the model is perfect. This is mapping the actual and the predicted very well. So that is the mathematical side of it. If you were in a classroom setup, you would have written the hypothesis function here, theta naught plus theta1 plus x, where we have said theta naught is 0, theta1 you have been given 0.5. So you calculate for each and every point. So you would have come here to start with this point, and the value here is, the x here is 1. So the predicted will be 0 plus 0.5 times 1, which is 0.5. That is the predicted. But what is the actual value? 2. So the error will be 2 minus 1. Okay, then you have gotten that error, which will be 1. Do the same for the other points, all these points here, with theta1 set to 0.5. Get that error. Okay, when you finish, go now with the same process when theta1 is equals to 1. Start from again here. Theta naught plus theta1 x. Theta1 has now been 1. The value here for x is 1. So 1 times 1 is 1 plus theta naught, which is 0. So 2 minus 1 again, the predicted will now be 1. So you go like that, get again, square those errors, get the value until you find the optimal. So that is the mathematical concept, ladies and gentlemen, behind the linear regression model that you build. So yes, you can do the coding. Tell GPT, write me a code for linear regression. It will write, but do you understand what that code does? This is what it does. This is how it computes that what we call that function, that result that you want. So the cost with respect to theta1, this is what it goes. So you have the cost function. Remember, the cost function is the errors that we got. Okay, so the errors that we had are all here. Then we have the theta1 here, which we are saying is set to 0, 0.5, 1, and all that. Okay, so when you are having this graph of the cost function against theta1, you should be having this value. So what happens is, where the value is close to 0, which is at this point 2 here, this point 2 here, so it will be okay to say at theta1 is equals to 2, the model is optimal. This is what the model does behind. This is the mathematical behind it. So it has the cost function, the result of the errors here, and theta1 here. So when it comes from, for example, here, when it is theta1 has been set to 0, the error is very high. We now go set to 0.5, the error is reducing. We come to 1.0, the error is still reducing. Remember, the cost function gives us the summation of the errors. That is the difference between the predicted and the actual. Then we come to 2.0, the error is now close to 0. Okay, then we go to 2.5, again like that. So this curve here is the biggest deal when it comes to regression. All right, that's how it goes. You can be able to change theta naught and theta1 in despite whatever values that will have, but the end goal is you want to have the most optimal value. So when you are visualizing this course, it looks like this convex function, or like a ball inside it, and this one you are trying to do it in a more 3D manner for you to try and see the error on what happens ideally behind it. So each and every point that you are seeing expected here is the data set that you have. So from here, you can be able to go root between theta1, theta naught, and the error. in a 3D manner. Okay, so when having that technique, we have a technique called gradient descent, because you have seen here, with values of theta naught and theta 1, you can change either for you to find the optimal. But for you to find the best way possible in landing to the optimal, we use a technique called gradient descent. So with gradient descent is an iterative optimization algorithm. So what we want to find the minima of a function. Okay, don't be worried about this mathematics. I'll share the slides later, then you can be able to debug it. Because of time, we just rush over, but I will want you to look at this very, very keenly. But this is the algorithm of the gradient descent. First of all, this derivative here is what we are calling the cost function. We have the one in respect to theta naught and the one in respect to theta 1. So in each and every iteration, because we are looking for the optimum theta, we first have to update the theta. So first of all, we'll have to pick the random theta naught and theta 1. Okay, this is what happens behind the code. We will get a random theta naught, theta 1, get the cost function. So the next one will either align below that value of the previous theta naught or above it. Why? Because when we have this minus sign, it really means that when we are having to move, or when we are here at this point, you see where we are here at the black point. When we are here at the black point, it just means the cost that we are having is higher than the optimal value here, 0. So what do we need to do? We need to reduce the theta so that we can come optimally to 0. Okay? In the other case, when we are at this point, 0 it is here, 0 is here. When we are at this point, then we are also greater than 0. That value is very, very, very greater than 0. So what we want to do, we want to reduce again, coming down this other way for us to have this value here. So if we had a plus sign, we will just be accelerating and we will never have reached the best optimal level. So gradient descent is an optimization algorithm to help you find this value here. You see the way it is going, calculating M and the changes in C. That is what happens behind that linear regression code. All right, so this is all about more explanation on gradient descent and everything. So sometimes you'll have more than one variable. So when you're training the linear regression model with more than one variable, that's what we're calling the multivariate linear regression. You have more than one variable. That means you have x1, x2, x3, x4, which could be, for example, if you want to predict the price of a house, what do you go for? Maybe the area of the house, square meters, area of the kitchen, maybe, probably. So all those are the features that you want to have. Then you want to predict them. So these are the features are represented mathematically. So this one here talks about the column 1. Okay, so it is read in a matrix form manner for you to read X value in row 1, column 1. So all elements in this area here are just the columns. So we go from 1, 2, 3, and everything. So the subscript represents the columns. The superscripts now are representing the rows. This is what is done behind the code. So we call them the row vectors. So when we had 1, it was just leaving as the hypothesis function just ended at theta 1x. But now because we have more than one variable, we now have theta 2, x2, theta 3, or like that, all the way until we have all these functions. So for us to be able to get the cost function, we will have to get the values of theta nodes all the way to theta n, depending on the parameters that are there based on the input features. Remember, when input is 1, parameter is 2. When input is 3, parameter is 4. Why are we having this? Because this theta naught here, which I'll explain a very, very big concept on it behind neural networks. And I'm very sorry, we have a very short time that we have to look at a lot of things to understand how they work, but don't worry about it. I think we could have introduced a series, it would have been more flexible. So when we want to have this product of the thetas against the values of the input features, for us to have a prediction, we will have to deal with even transposition. All right, so again, this is what happens. Find the initial values, pick random values of the thetas, find the cost, If they are nearing, reduce the cost. So we are updating the cost based on the previous cost. That is why you are seeing the theta here is minus. So it is the previous theta minus that and get the new one. Iterate again. Okay. Oh, this is a question that I was supposed to ask you. So far, are you okay mathematically? All right. So that is what happens behind the scene. You have the gradient descent here. It is degrading, degrading. Oh, this is good until we reach to an optimal level. But when you have the gradient descent coming from here, you can see the steps here. The steps are very, maybe a little bit big and a little bit small. You see this step here is what we are calling the learning rate. So when you have a small learning rate, in this case here, that means you are moving slowly. Where is that learning rate? It is here, this alpha here. So alpha here is the learning rate. So if it is 0.5, you see, it is very small. The changes are very small. But if it is 5, it will be 5 times that cost, 3 times that cost. So this learning rate is very, very important. Have a serious learning rate that you'll be able to observe with it. So if it is small, you'll be just making baby steps. But again, if the learning cost is very big, let's say you have put like 10 times the error that will be coming there, you will be just keeping the cost from the left side all the way to the right side like that. It will be difficult to reach the optimum. So have an optimal learning rate for you to have about it. So, sorry, this is all for a classroom setup, but again, time is very small. Let us just look at scaling. So you have a lot of data, numerical data, and this whole type of data, you can't train a model and you're having input as 10,000 and you want to train it with the 10,000. No, we do a lot of feature scaling. So we want to harmonize all the values. For example, there are parts of the data that are decimal. There are parts of the data that are whole numbers. Normalize all of them. So we have different forms of normalization or standardization. Mean normalization means get the mean, subtract each and every input based on that mean, okay? Then we have standardization. Standardization is very different. There are those standardization that will give you areas of the values centering on the standard deviation. So if the standard deviation is 2.5, that now will be the range where we'll be joking with. But if there are also another standardization method which deals with 0. So it is either between 0 and 1. Okay, so once you feature scale that all data, you can be able now to train your model very well. What is the effect? When you have a lot of feature scaled data, then my friend, the model of course will take a lot of time. So we have to do all this translation and everything. So this is what happens, ladies and gentlemen, at the background of your code when you're dealing with linear regression. We have the data node that is being updated. We have the iterations that go on, because when ChatGPT to write you that code, it will tell you, okay, what are the number of iterations, but you don't understand what that iteration means. This is what it means. Iterate, iterate, iterate. Get until we get the most optimum value. And the most optimum value is this. So you can see when you're having data node is 23.36, the cost is 34. So once we go reducing till the node, you can see it starts with 23, then it goes all the way decreasing. And the difference also decreases and the cost also decreases, but that is after iteration 1, 1,000. That is what happens behind the wheels. So that was on the regression side of it, where we are talking about the prediction of continuous variable. We have another one called logistic regression. This one now will brush very quickly. So this logistic regression is very simple. Hii ni kitu simple kabisa, just 2 minutes and we will be done. Very simple. Then we go to a demo whereby we now talk more, because I understand we have a simple like that 2 minutes to go. And we'll have also to talk a bit of LLMs and everything. All right. So in logistic regression, what happened in linear regression? We were predicting continuous values. For example, what is the house price? Okay. You get the continuous amount of value. But in logistic regression, we want to classify. Okay. So we want to do classification based on 0 or 1. It is a categorical classification, but we are calling it logistic regression. The other one was all about continuous prediction, like the amount of range. We need train. So it gives you value. Yes, 1, 0, no. But you have trained it with mathematical data. So this is what we have. we have the energy of an electron as an example here, and we have 1. So depending on the kind of vibration that the electron will have, and this one we are assuming the superficial hitting of a metal surface, whereby now the electrons are bouncing and everything. Yeah? I'm using that example because all of us come from different domains. I heard there was somebody from agriculture. Let me tell you one beautiful thing about AI. It is every field adopting AI, but not AI adopting every field. So whether you are in arts, find a way how AI comes to what you want. And now it will be very easy. So when you are dealing with somebody and they have, maybe for example, they are telling you, oh, I'm passionate about dancing. Very good. Let us show you how you can do the dancing together coupled with AI. So it is every field adopting technology, and this respect AI. So no matter where you are, agriculture, farming, physics, and everything, because these are physics example, and everything and all that. So for example, in agriculture, you would want to detect the temperature or the moisture, and you want to deal with a linear regression model to predict whether the water levels will be rising or will be low, the humidity, so that you know when am I going to water these cabbages. Okay, I will talk to you about possibility of multidisciplinary approach when you're dealing with AI. So that will be linear regression coupled with agriculture. And the simplest way to deal with it is by having sensors, okay? So these sensors will be collecting numerical data, all right? So of course, whatever we're receiving there in the sensor is a numerical data. You remember when you say we see, how does AI see? How AI sees is what we call, how does AI perceive from the environment? And perceiving from the environment is what we're calling about sensors. So these sensors is one of the most important things. So the sensor comes, you take your data, and this is the way to have it is by having IoT, that is Internet of Things. So code like a device there, put it somewhere, like Arduino there, read from the sensor, okay? Get the temperature levels, get all these levels and everything. Put that data into that model that you have created. So here now we are combining two things. Internet of Things, using this hardware device, and machine learning, where we are training a multivariate linear regression. The data we are receiving, we are getting maybe a temperature sensor, humidity sensor, whatever sensor that can give us data relevant to soil. Okay, we are now training it to this multivariate linear regression model. Good. The output that we want is, will we be able to, should we water the nini again? So if the levels, depending on what you agree as your threshold, maybe if the humidity predicted will be 22, then you realize, okay, those cabbages need water. Okay, so that one will be one of the ways in which we have been able to combine IoT and linear regression in that manner. So when you're dealing with the logistic regression and you want to classify something into X or Y, a straight line can't work. Why? Because in this variation of this straight line, we'll have a value here. From here, well, let's say from here to here, you'll have a value which will be maybe 0.1. But you want a continuous, you want a categorical thing. So linear regression is a problem. We can't apply linear regression in this sector. So what we want to introduce, we want to introduce something that is called a different mapping function. Okay, so this mapping function will be able to give us the range between 0 and 1. So you remember the mapping function for the linear regression was all about theta 0, theta 1, and x. So here we have 1 over. So we want to introduce a sigmoid function, which will now be better like this. And then that model, for example, in agriculture setup, you will now be given as, hey, water. Hey, cabbage need water, yes or no. Okay, so this is all about linear regression, having things to deal with the decision making. And the biggest important thing about this one is about the decision boundary. For example, any value that falls below 0.5, then we say, now you are below 0.5, then you are nearing 0. You are just be called 0. Okay, then any value that is from 0.5 and above, let that be +1. So that categorization is achievable when you're dealing with the numerical data, and we call it logistic regression. So when you're dealing with the multi-classification and you have a problem in linear regression, you see the kind of problem that you're having. So when you introduce linear regression here, you can't be able to draw any line that can be able to deal with multi-class classification. So that's why we have the concepts of logistic regression. So now, before I go to under and overfitting, which is a very pregnant concept in everything that we shall deal with, allow me to do as a demo in AI for KSL that will be able to show you guys how we deal with these different types in terms of application. So just a minute, let me share a different screen here. Then we can be able to tell the application, because I'm telling you all this and it is a mathematical side of it. Iko mtu amekaa hapo anashindwa kwani niko dunia ingine, right? So I'm not sure if my screen has changed. All right, this is cool. All right. Thank you very much. Now, you see, we have talked about mathematics a lot. Let me now show you how it comes to being. AI for KSL is a project that we are calling Artificial Intelligence for Kenyan Sign Language. Okay, as I told you before, AI, its essence is narrowed down to the data. That data is what fuels AI. Right? And the kind of quality data that you have, most preferably will detect from the kind of quality model that you will be having. Okay? I don't mean that when you have all quality model, then your model will be good. No, it also depends on the kind of algorithm that you are having. All right? So, in collecting sign language data, of course, it's a multidisciplinary thing. Personally, me, I don't know sign language. So we'll have to do a multidisciplinary manner for us to be able to collect this data and guarantee that the data that we are having here is of quality. Okay, so we did collect data in different schools and in different stratas of the sample. For example, this here, what you are seeing here is a technique applied that is called computer vision. And this technique of computer vision is one that can help you even as a farmer. And let me use the agriculture sector. You want to predict whether it is the cabbage is fresh or it is not fresh. You can do that also using pictures of the cabbages. Have a model, okay, where in this case, when you're dealing with images, we deal more with what we call a CNN model. So CNN models have been made correctly to predict and classify and deal with image operations. So in our case, we went and collected video data. So how does videos and images relate? I will argue a video is concatenation of images in motion. Because in a video, you can be able to get the frame. So one, computer vision, you can be able to do classification, all right? You can be able to do tracking, which falls under a technique that we have applied here called pose estimation. So in pose estimation, the technique of pose estimation allows you to get different landmarks from the human being. Okay, when you're dealing with robotics, there are two ways to go about it. I think this one was done by Signverse. So for us, we collected video data and we trained our model based on video data. But for Signverse, they're also dealing with sign language, but for them, they are recording their sign language data based on sensors. Okay, again, remember, the biggest deal in an AI project is on the data side of it. Once you are done, actually the project is like 70% done. That is if you are collecting primary data yourself. So we collected this primary data, did a technique called pose estimation. And in pose estimation, we used a package called MediaPipe. MediaPipe is from Google. We have another package called OpenPose from different vendors and everything. So in pose estimation, we want to extract landmarks while making sure you are anonymous. Remember, these people are signing even with their face in terms of lip syncing, in terms of facial expressions. And I would argue, what is communication without expression? So having a proper mechanism of getting their facial expression is also important in designing an AI model for sign language, right? Correct. You can say, you can imagine a hearing impaired person signing I love you and they're not smiling. You know, it will destroy and distort the meaning, relevance, right? So we did pose estimation. So you have a one-to-one mapping between the signer, the video data that you have. This one now is dealing with videos. There are those ones that also deal with images, okay? So you'll have to do CNN way pipeline, process each and every frame. So each and every frame, you can see he's wearing something like a green t-shirt. You know, there are some people who argue that men are colorblind, but when it comes to identifying light-skinned ladies, they are not. Anyway, so you can see he's wearing a green t-shirt. So when we are doing pose estimation, we'll have to convert this from RGB to BGR. so that we can get the grayscale. After getting the grayscale, then we can do framing. So in the framing, we want to identify the edges. Media pipe, or in pose estimation, you can get the movements of the face in what we call the landmarks, which is face landmark extraction. You can have a package that deals with the hands, which is what we are calling hand tracking. You can have another package which deals with the whole body, which is what we are calling pose estimation or full landmark estimation. Okay, so after this, we collected videos, all of them signing, and they were different. Just camera on, you sign. As much as we have the sentence and the text of what you want us to say, what you are saying, then well and good. After that, we went to segmentation. Remember, you have just turned on the camera, you sign, but we make sure we have these sentences. So they have signed in sentences, okay? The video is there, a whole 1 hour. So we have to do segmentation from the whole video, segment it to different sentences. But again, we have to train the AI model using words, because the words are what formulate the sentences are the primary structure. So we come to word stigma. So we get the landmarks, segment them into different words. Then we created a model that will be able to do signing. And in our evaluation, or in our evolution, rather, you had the stigma. But this guy here is not presentable. Okay, we introduce now a robot here. But now the robot is not human. How do you expect them to do this in class? Then we introduce avatars here. So avatars, we use them. We created avatars. These are AI gaming avatar platforms that we used. Because you see, when you compare the avatar that you see in a PS5 and you compare Superman, all those two things are very different in terms of quality. Then now we have the videos. We have the text. We go ahead in training. All right. So in the process of creating the model, we collected also the text of that what they are signing, because we need to have relevance. Okay. So in the signing, but let's take the video, let's take the sentence or the word. Now, we also collected sentences of the Luo text. Currently, we have collected from Mijikenda. We have also collected from Somali. We have collected from Kikuyu. We have collected from Maasai and from Kalenjin. Okay, just to have the 8 regions or provinces well balanced. So this narrows back again to my biggest point of the day. AI is nothing without data. Okay, so where you are, no matter what ethnic community you come from, how do you make sure that you are contributing to the evolution of AI? If you are the Luo speaker, for example, and Facebook are building a model that will want them to combine a Luo chatbot, how do you come and contribute to that model? So I've shown you this side of the data set, which is the computer vision side of it. And remember, in computer vision, I told you, is what helps the field of AI to have a person who can see, who can perceive. Okay, because in computer vision, you have a lot. This is just tip of the iceberg. For example, autonomous vehicles. You know, they have cameras which feed in, and the cameras, they now scan the environment. When you are dealing with computer vision, or when you are dealing with AI agents, you have to be clear on kind of environment. For example, in a road environment, there is a lot that is happening. So they have the cameras there which perceive from the environment. All right. So those things that perceive are what we are calling the sensors. So they give into the model. Then when the model makes a judgment, there is a logical unit in the structure of an agent that deals with the processing. So when it makes a judgment, it again has to act on the environment. So if it has seen a red light or it has seen somebody crossing, what will it do? It will stop. What does it use to stop? The brakes. The acts or the parts used to give feedback to the environment are what you are calling the actuators. Okay, so actuators react, sensors perceive. When you're dealing with AI agents, that's how that's the logical flow. Okay, so back to our narration here. After collecting the sentence, we now want to train the model. Now, we have trained this model on what we are calling Facebook NLP 200 here. And let me tell you, by the way, when we are dealing with AI, there's a lot that has been done about AI. You are not the first one. Okay? You are not the first one. So the best thing when it comes to models, first start with existing models. Okay? So we have this Facebook, NLP 200 is still 600M. We also have another one that is 1.3b. Let me just bring to so that I explain to you how these things are. We have this NLP distilled 1.3b. Now, the 1.3b you are seeing here are the parameters configured in that model. Okay, you remember in earlier regression, we had two parameters, theta naught, theta 1. That's very simple. But in this model that has been developed by Facebook, has 1.3 billion parameters. By the way, let me introduce you guys to Hugging Face. Hugging Face is a very big AI platform where if you want to deal with the data sets, you can come here, look at the data sets available, whatever data sets that you would want to deal with. When you want to deal with already existing models, for example, if you want to develop a llama model is one of the models that are being used here greatly on LLMs. You can train that model from scratch. As you have seen, it is 1.3 billion parameters. You don't have the machine. Can I compete with Facebook? I can't. So there is this concept of pre-trained what? Models. Okay? Then the pre-trained model, what you need to do, have the pre-trained model first. In the pre-trained model, have your data. So what you want to do, you want to somehow, let me put in bracket, customize that model to act based on your data. All right? So what we'll be having a snapshot of that big model. All right. So that's how everything works in machine learning. Even if you want to create ChatGPT, we have GPT-5. Here in these models, you can find GPT-5 here, among other big LLM model. LLM means large language model. And in their training, they do a lot of text. So you see like this one for Facebook LLM, NLP. NLP means no language left behind. Okay. They have taken a lot of language data or text data from the platform itself. How many people are on Facebook? That's a lot of data. So I can't compete with them. Read here, 196 languages. Where will I get 196 languages from? Even when I start collecting today, 2030 will reach and I'm yet, right? Depending on the quantity. So these people have already designed models that already exist. When we are dealing with audio, I'm just taking you through the prerequisites of all this so that we can be able to. So when you get out of here, go look more deeper into LLMs, go look more deeper into ASR models. We have a model called ASR model. And ASR models are very heavy models because they deal with speech. That's why the way I'm talking to you, you see the Siri in the iPhone. So it is like, hi Siri. How are you today? You know, the response, that's an ASR model in generation. So we have a whole concept that binds all of them that is called transformers and generative models. So ChatGPT is a generative model. Okay, they generate. Their work is to generate. They can either generate text. That's why you can tell it, you can give it a question and it answers. They can able to generate an image. So if you want all that, they are already pre-trained models. Your work is to just customize. But note, you might be requiring what we call what we are calling GPU, heavy resource, okay, to be able to customize them to be based on your data. So we have all these models. We have speech. I was there on the speech side of it. The languages, I've told you, we have 8 of them. In the Masano lab, we have collected 8 of those, and we are training an ASR model that will be able to cover all those. We have Whisper model. Whisper model is also a big model that has already been pre-trained. So can you imagine me customizing 1.3 billion? Hii Constantine Wesonga akisikia si atadhani kwa ile 7.9 billion ya CBA nimetoa kitu. But these are parameters for the model. Okay, they are very heavy. So just deal with pre-trained models if there is one applicable to you. Okay, yes. So we use that model to come up with this model here. So when we're dealing with sign language and we want, for example, to translate, let's say like my country is Kenya. Then you want to generate. You remember the computer vision side of it that I've shown you? So these are multidisciplinary. We have NLP and we have computer vision. So you now have the avatar doing my language is Kenya. I mean, not my language, my country. Sorry. my country is Kenya. So any text that you put here, you have the sign language equivalent. And the beautiful side of it is that we have mapped them in either form of the avatar that you want. Female avatar. Let us see if it can do the same for female avatar. My country is Kenya. Okay. My country is Kenya. Okay. Right. So that customization and everything is part of, you see, for example, if you love fashion, you can bring AI in the avatar design creation and the customization and everything. So when we are now done with that ASR that we are working in the lab here at Maseno University, we will combine to here so that you don't have to type. Okay, just record yourself. So next time, when you see somebody who is hearing impaired, don't go out looking for an interpreter. Just use the platform, type, record, then it will give you the sign language equivalent. All in all, the reason as why we went for an NLP model is because we have different levels of signing. For example, there's what we call gloss in Kenyan Sign Language. So when we are saying like today is Monday, or let me just type tomorrow is a good day. Is a good day. Before they sign, they first do glossing. Glossing is whereby they alternate. So it now becomes tomorrow, day, good. So there's a whole sequence. So they use the subject, verb, object. Okay, that order for them to be able to sign. So that signer that you see on the television while watching news, anakuanga ameekewa hii, the gloss, we call this the gloss. Tomorrow, day, good. Then, for example, comma, Baba Nyayo Stadium, for example. So ule mwingine akisoma kwa teleprompter, the text ya chenye anafaa kusoma kwa watangazaji, huyu naye anasoma yake based on this gloss. So aki roll, camera roll, and the news have started, ataanza sasa signing ya tomorrow, day, good, like that. Okay, so that is the syntax of Kenyan Sign Language. So now, as we are diving more into LLM, allow me to welcome Edwin so that he can tell us. Remember, we are talking about generative models. Okay, sasa hii maneno ya linear regression ilikuwa kukuonyesha the mathematical side behind it. Ndio ujue tumetoka mbali. Okay, so allow me to welcome Edwin so that he can take us through what he has been doing in terms of NLP. Remember, we said AI now is talking. Hi Siri. GPT is understanding now Kiswahili. How is that possible? So let me welcome Edwin on the platform so that he can be able to take us through that. Yes, Edwin.
Yes, thank you so much, Ezekiel. I hope I'm audible enough. Oh, yeah, thank you. So, I don't know, Ezekiel has covered a lot, but I will try and maybe talk on NLP. As we've heard from the start, he stated that AI is huge and it has several fields. One of the fields is NLP, which basically tries to, we are trying to train machines so that they're able to understand, and after understanding our language, they're able to interpret and respond to humans in both spoken and written. Now, there are several areas in NLP. We have that is text classification, machine translation, the one that he has showed you. We have also that is part of speech, question and answering, speech recognition, and even text generation. That's just some of the areas of NLP. But now my focus is on text classification, whereby I came up with a model that is able to classify short Swahili sentences into 12 broad domains. I don't know, maybe let me share a demo of the model. And before that, the model that I developed is an XMLR model. And for those people who don't understand what this model is, it's a cross-lingual language model. And basically, this model is a multilingual model, transformer-based model that has been developed by Facebook AI. And the reason why I chose this model is because it has been pre-trained on 100+ languages, including Swahili. And based on what I've told you, the task that I did is on Swahili. So it is easier for this model to understand this language. Allow me just, before I take you to the demo itself, allow me take you through a few things. The reason why I chose that is Swahili is because Swahili, you people understand, yes, it's being spoken by most people. That is over 100 million people across East and Central Africa. Although it's referred as a low resource language because it has a few data sets and a model, and in terms of even technologies, it has a few compared to these other languages like English. That is why I focus on Swahili. And NLP, I understand each and every person in this meeting speaks at least a language, a local language. I understand there are Luos here, we have Kisis, we have Kalenjins, we have Kikuyu. And I've said there that NLP basically deals with training these computers so that they are able to understand this local language, rather than humans being able to understand that is the computer language. Because of time, allow me just go to the demo itself so that you see how the model works. It was developed using the Streamlit, and just a minute. Yes, I hope you're able to see it. So this model was trained on Swahili data that has 30,621 short Swahili sentences. What do I mean by short? Short Swahili sentences in this study was, just a minute. Yeah, yes. Short Swahili sentences means these are sentences that have a maximum of 200 characters. So more than 200 characters was not ideal for this study. We only focus on the short text data set. So the first thing that we did is curate a data set. That is the size of the data set is 30,621 sentences. So this model, you give it a Swahili sentence, and it's able to classify it to one of the 12 topics, 12 broad topics. So, for example, there are a few sentences that are here, like this one. Let me start with the first one. Nataka kwenda sokoni. When you classify this text, it will classify it under business and finance. And clearly you can see there that that sentence falls under that topic. There are also a few sentences here. Like for instance, this one, zahanati ya kijiji imepokea vifaa. Yeah, this one, if you classify it, it will classify it under healthcare. Allow me also, maybe I understand there are people who like football here. So let me just give an example of kijana huyu anapenda Danda. So this one, it will classify it under sports and entertainment. The model works. I didn't want to go more into detail of how the methodology that I used and everything, and even the evaluation and everything, but the model works well. For more information, maybe I'll share a link so that you're able to work with it. Before I finish, also, there is, I don't know if you people have seen, there's a model that has been developed by Sunbird AI, that is Sunflower, that is able to just translate English language to the 20 plus Ugandan languages. So you give it any language in English, you give it a text in English, then it's able to translate it into, that is one of the 20 plus languages in Uganda. Just try it, and you can see it is the reason why I'm telling you about this Sunflower is because one of the concepts there is NLP translation. I talked about machine translation, and this one is a model that is a large language model that is able to translate, that is English to one of the 20 plus languages. Otherwise, thank you. I think I'm not going to talk more than what I've said, and back to you, Ezekiel.
All right. Thank you very much, Edwin. Clearly, you see, that is the ideal case of one of the applications behind the development of AI. So, for example, when you look at that model by Sunbird, and they are doing it to their own local languages, the big question that you should be asking yourself is, what are you contributing towards AI in Africa? It is very impactful in different fields that you have, whether the field you are in is in agriculture and in everything that you have. The simplest rationale still remains that we will have to collect data. We'll have to do a lot of data collection. You can look at Ken Corpus, that is a Maseno consortium, where we are dealing with Kenya Corpus. So we are collecting a lot of textual data, and we are looking also for, in terms of contributor side of view, those people who are giving us this data and everything. So in the advancement of Kenyan AI, perhaps I should ask you this question. Where are you? Are you giving us the data? Are you the practitioner who is giving us this model, so that we stop the big issue of we are behind in terms of AI? There are big giants out here dealing with everything. So in terms of everything and everything, when we look at different models, remember the takeaway from this snapshot is that different models, some of which we are dealing, you have seen Edwin's case is on XMLR, is already a pre-trained existing model. What it does, do a lot of training for that model, do a lot of data set preparation for the model, and all will do well. Again, narrows down to the splitting. Perhaps he could have told us how he splitted, the ratio of his splitting and everything, but that also is one of the remarkable things. There were a lot of things that I would like us to talk about, ladies and gentlemen, a lot that would have been almost more than a snapshot on how we do the validation. Remember when we were talking about the data set splitting? So I have like 3 minutes. Let me just brush you off with what is remaining, so that perhaps you could be curious and go look more about it. In validation, we have the K cross fold validation. So this one helps us in avoiding less generalization. So each and every fold, depending on how we split the data set, we have the steps. So four of the folds, we now have the training, one remain the testing, or like that. So it's a cross-fold validation. We have the type of errors. Remember when we were talking about the errors in our previous classification, in classification algorithms. Now, here is where I want now to stop my case, the confusion matrix. The evaluation that Edwin must have had, because it's a classification problem, so he ought to have classified, then categorized the results based on a confusion matrix. This is how a confusion matrix works. If the actual and the predicted are the same, that is a true positive. Are we together? So that means, yes, maybe let's use in terms of a boy child. The screening showed, yes, this would be a boy, but the baby born is a boy. So that one is a true positive. When it is false, that is, we are matching the other class with the other class. That means the class that has been predicted is not for the super class that you're having. That becomes a false positive. In short, when the actual class and the predicted class match, and all of them are true. So this variable, whether one is true or one is false, depends on what you're tackling. Okay, there are also instances where we come a lot with issues that deal with super complex. You know, this one is just for two variables, 1 and 0. So for Edwin, he had 12 classes. So if the actual class, it is 12. So then the confusion matrix that he made must have been 12 by well off because there's the actual and there's the predicted. Look more about these confusion matrix. Different people understand them different ways, but all these are all about the performance measure, how we evaluate if it is a classification. We have the matter of accuracy. We have another one called precision. We have the true positive rate, the false positive rate, all those. Now, there was still one very, very big concept about bias and variance. This one now, again, also narrows down to the performance, just taking you roughly through in the remaining 1 minute so that at least you can go and look at that. Neural networks. Now, when we moved from these simple models, it now became a problem. Why? Because we are now having complex data. And remember, AI is about mimicking human beings. So that is why we have a concept of neural networks. As we use the brain to think, and the brain is really made of the neurons. So you remember when I told you plus C, where they were telling us the C is the y-intercept. Now to neural networks is very important because if you're having y is equals to mx plus c and x is 0, and you don't have the C, y will also be 0. So in neural networks, it is important for that C to be there. Because if you even get y is equals to 0, then it will be that plus C. That means it will fire. So neural networks is very, very complicated section. I had a lot. This slide actually is almost 200 plus. But as I said, and I think Maina should be asked a comment on this, that is Leon, we can't be able to exhaust AI in a simple session. So it's up to you. Be curious, find more. In neural networks, the biggest performance on this is about what we call feed-forward propagation and feed-backward propagation. So feeding forward, we have the X1 here, maybe I can narrate, the X1 here, X2, all the way to the value. So these X's are the input variables. Remember when we were saying the input variables for different, like the sensor gave us this, then they have to go to another activation function. So we have the weights in here between these edges here, we have the weights. So when it is y is equals to 0, it won't fire to the next neuron. The structure is like this. Leave alone, good. The structure is like this. So we need to have this connection that come back to the dendrite branches here for your brain to work. And that is why you'll find there are some of the things that people do, but it is just because they have been used to and has been wired to the brain. For example, mlevi anaweza kuwa amelewa, ameenda Habanos, amechachisha kama kitu ingine, hata kutoka where he is seated to the vehicle haezi enda. But the same person, mkimbeba mkiwa mbugi, mumemweka kwa gari, ata drive safely with no accident. In the case of a truck driver. Why? Because it is a routine. Whatever you do daily, now moves from the neocortex to the other brain. Okay, so all those incidences, the neural network is really about explaining how the brain works. So you have the inputs, the weights, then you have this bias. I've told you the importance of this bias, which is now what we are calling the C there, so that we may fire to the next neuron. It's all about moving to the next neuron. Backward propagation, we have now the output here. We now go back so that we can have an optimization. So gradient descent helped us to get better parameters. So in backward propagation, we will be able to do optimization of these weights. Okay, ladies and gentlemen, let me leave you at this point so that we can be more curious on the next one. Go look onto why did the concept of neural network come. Go look at transformers and generative models. Those are also big concepts in the field of AI. So ladies and gentlemen, allow me to end up at this point. It has been a pleasure having you around. Thank you very much, Bill, for the invite, and thank you very much for my co-host. Asante sana. Thank you all for joining. Thank you.
Yeah, thank you very much, so Mr. Maina, or can I say Engineer Maina? Thank you for that incredible session and for breaking down AI and all that. And to be honest, I've never had anyone talk about the AI or the math behind the AI with such excitement. So we thank you for your time and all that. So I would like to invite, if you have any questions, just to, because of time, if you have any questions for Mr. Maina about anything that we've that is talked about during this session, you can raise your hand or you can type in the messages section. Do you have any question? I saw one here. Engineer Jesse was saying, can you share slides on today's lesson, sir?
Absolutely.
Mr. Maina?
Absolutely. We'll work on that. I will ask with Billy on that.
Yeah, so with Engineer Jesse, I've shared some two links, one for registration about data analytics course and one for feedback. So you can fill any and then we'll take your information from there and then you can get the slides. Any questions? We don't have any questions. Okay, we can continue. Yes, I've filled the form already. Okay, thank you, Jesse. We'll contact you. And the notes will also, the slides will be shared with you. So thank you for your time, the audience. And before we wrap up, I'd love to share a little about Codevertex IT Solutions. That is the team behind this event. So we are based right here in Kisumu. That is a Pioneer House, room 204A. And our mission is to empower individuals with real practical tech skills that open doors to global opportunities. We have courses. Let's say you come from college and maybe you have you did a general course like in ICT, and then you want to find your specific path. So we provide such courses that guarantee you, so that you have the skills that are required in the job market. So with that, we have courses in software engineering, artificial intelligence, data science and data analysis, IT support engineering, ICDL. We have a lot of courses, digital marketing with AI. Like we've said, the world is going AI. AI revolution is here. So with everything, you need to ensure that you are at the same par with the industry. Okay, since tonight theme connects closely to data and AI, let me highlight one of the most in-demand programs we have at Codevertex, that is data analysis. This course is designed for beginners and professionals who want to master the art. I had earlier, while you were introducing ourselves, I had someone say that they're new into tech. Not exactly new, but they're changing into it. The guy was, he did something in agriculture. So yeah, we welcome such people. Either you are a professional, you're a beginner, or you are a career changer, you are welcome. And you learn how to collect, clean, and visualize data. You heard that the AI that Mr. Maina was talking about, it's mostly about data. So once you finish everything about data, that's 70% of work done. So you and visualize data, use tools that are there there in the market, and most importantly, and how to turn the raw data into insights that drive decisions. Like the example that you were given by Mr. Maina about the sign language, how to using AI to mimic a sign language from real people. So that is, they collected the data and then they made such a decision. So it's a practical hands-on course, and by the time you finish, you'll be able to analyze real data sets and present reports and do anything else. You can either you can look for a job or you can be self-employed and look for work yourself. So if you're ready to take your next step, I've shared the important links. I've pinned them in the chat section. That is the registration form for our upcoming data analysis course. You can register, you can show us your interest, and then we'll move from there. And also we have a feedback form. I'll really encourage you to give us your feedback and tell us what you've learned, how we've helped you, and maybe in our future masterclass or webinar, what you'd like us to talk about. We normally have these webinars every Friday, every Thursday from 8 p.m. to 9:30 p.m. Sorry, today we've kind of taken most of your time. Sorry for that. But with the AI, you already know that it's a lot of content and all of it cannot be shared with you within an hour and a half. So maybe through your feedback, we'll see if we'll create another event for AI or whatever you want, or whatever you want to learn about. We'll see how to go about that. So once again, a huge thank you to our speaker, Mr. Ezekiel, for sharing your time and expertise with us. And thank you for all of you who joined us tonight. Your engagement, I saw you engage, even if you don't have any questions. It was very lively through the emojis, that is. But thank you for your time. Remember, the future belongs to those who learn new skills today. So don't wait. There's never tomorrow. You never know what will happen tomorrow. So if you want to do something, if you want to take a course, if you want to skill up, just start today. Okay, I'd like to invite Bill to give us a closing remark, and then we just 2 minutes, and then we'll let you guys go about your business for tonight. Bill, welcome.
Okay, thank you, Shirley. Thank you, Maina. And so I think like I've learned a lot from the event. Thank you, Mr. Maina. So I think we are going to call you for some like event on either NLP or maybe something to do with like vision. Yeah, so like from the event, I think and I think like now like social the power like of AI. So maybe like I just like urge each of you to make sure you begin now, do that project, go for that hackathon, take, and take that because now like AI like is here with us. So either you shape up or you like you die. So I think like time has gone, and I'm just going to wish you some good night. We love events like this like Thursday, so make sure you follow our pages on Facebook, LinkedIn, and X. Then we also have some hub area like we teach these things. So you are all welcome to join. So thank you, Mr. Maina, again for coming here and sharing like with us most of your knowledge. Then I see we had some team from Simba AI. So maybe I'll call them next time so that they can share with us more about what they do. So I guess with that, back to you, Stanley.
Okay. From all of us at Codevertex IT Solutions, thank you, and keep learning, and have a wonderful evening.